We're going to continue talking about simple probability. When I talk about probability, I'm still talking about the favorable outcomes divided by the total number of outcomes. When I talk about an outcome, I'm really talking about the possible results of an experiment. So a possible result from this graph over here, we're rolling dice B and dice A. We're rolling 2 dice. They each have 6 sides on them. So we have a bunch of different options. We can roll a 2 through a 12. We can roll anything from a 2 to 12. Rolling a 10 is a possible outcome. On this graph, there's 36 total outcomes. Outcomes are really just different things that could possibly happen in an experiment. An event is one or more outcomes. And we're going to write that in a really mathy way. I'm going to use that same example. The chance that we roll a 10, or the probability that we roll a 10, is going to be written like this. The P, or probability, of rolling a 10. And I'm going to do a second example also, just to show you how else this could possibly be written. So I'm talking about the chance that we roll a number greater than 10. So that means an 11, a 12, or another 11. Any of these 3 options. The probability of rolling a number or an X that's greater than 10 could be written like this. The probability of rolling a number that's greater than 10. So each of these is actually an event. It's one or more possible outcomes, just described in a mathy way. Probability of this thing happening. And again, just to review, the probability of anything is the chance of an event. Likelihood that that event actually takes place. So the P of 10, or the probability of rolling a 10, well, there are 3 different ways that we can roll a 10. We can roll 2 5s, we can roll a 6 and then a 4, or we can roll a 4 and then a 6. So there's 3 different desired outcomes for rolling a 10 out of the total, which is 36 possible outcomes. The chance that we roll a 10 is 3 out of 36. If you're going to write this as a fraction, it should be simplified. We can divide the top and the bottom by 3 to simplify this fraction. That really changes into 1 out of 12. You can also write it as a decimal or a percent. Those are all the same. Here I'm just going to keep it as a fraction. So the probability that we roll a 10 is a 1 in 12 chance. There's about an 8% chance that we roll a 10. The probability that we roll a number that's greater than 10 equals all the different outcomes that are greater than 10. So it's got to be bigger than 10. That means that it's either an 11, or that 12. We can roll a 6 and then a 5, or a 5 and then a 6. Or we can roll double 6s. Either way, that's bigger than 10. That gives us another 3 out of 36 chance. And we obviously know that's going to simplify to 1 out of 12 also. Right, so these probabilities will always be between 0 and 1. 0 means it can't happen. 1 means it has to happen. This should say impossible over here. So it's unlikely that we get a 5 on a die. That's a 1 in 6 chance. The chance that we get a blue one out of this group of circles, if we just randomly pick one of those circles, that's a 4 in 5 chance. That's a pretty good chance. That's an 80% chance. This is about a 16% chance. All right, so now we're going to do these example problems. All of them are talking about rolling 2 dice, which is what this chart is talking about. This is showing the options for dice A, the options for dice B, and these are the possible rolls that we can have between both dice. So that first one is asking, what's the probability of rolling a 15? You can't roll a 15. with two dice that are numbered 1 through 6. The highest we can roll is a 12. So the chance that we roll a 15 is 0 out of 36, or a 0% chance. What's the probability of rolling a 4 or a 10? I got 1 4 there, 1 4 there, 1 4 there, 1 10 there, 1 10 there, 1 10 there. So there's 6 possible options. There's 3 4s and 3 10s. That's 6 out of the total possible options. That's 36. Again, if you're going to write it as a fraction, I'm going to simplify it. You can divide the top and the bottom by 6. That gives us a 1 in 6 chance that that happens, or a 16.6% chance. What is the probability that we roll an even number? I'm going to count up all of the possible even numbers. That's 2, 4, 6, 8, 10, and 12. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 options are even out of the total of 36 options. That's 1 out of every 2. Maybe you could just see how I simplified that. Really, that's half of the options. Or you could think of this as divided by 18 on the top, divided by 18 on the bottom. That simplifies to that fraction. There's a 50% chance that we roll an even number. Next one is asking, what's the probability of rolling a number greater than 4? Okay, so we can count up all the numbers greater than 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There's 30 options that are bigger than 4. 30 out of 36. Again, I'm going to simplify that fraction. The top and the bottom can both be divided by 6. That would give me 5 out of 6. So there's about an 83% chance that we roll a number greater than 4. That's a pretty good chance. What's the probability of rolling a number less than 13? That is a 100% chance that numbers less than 13, every single number that we roll is less than 13. So that's 36 out of 36, or 1, or a 100% chance. Number 6 is asking, which event is most likely, rolling a 7, rolling a 3 or a 6, or rolling doubles? We've got to compare each of those. What's the chance that we roll a 7? So we have 1, 2, 3, 4, 5, 6 7s on the board. So there's 6 out of 36. For a 3 or a 6, we have 1, 2, 3, 4, 5, 6, 7. So there's 7 options out of 36. And then rolling doubles. Doubles is a little bit tougher to find. We can't just look at the chart itself. We actually have to look at where this lines up. Basically a 1 and a 1, a 2 and a 2, a 3 and a 3. It's actually just going to be this diagonal going across. 4 and a 4, 5 and a 5, 6 and a 6. That is 6 options out of a total of 36. 6 out of 36 possible outcomes. So the answer is rolling a 3 or a 6. That has the best chance of happening. That's 7 out of 36 versus the 6 out of 36. Which of these events is least likely to happen? Rolling less than a 4, rolling double 6s, or rolling a 3? Right, rolling less than a 4. That means either 3 or 2. Rolling a 3 or a 2 is 3 possible outcomes out of 36. Rolling double 6s, there's just 1 double 6. That's the only way to get a 12. So it's a 1 out of 36 chance. And rolling a 3, that's 3, that's 3, so there's 2 options out of the total of 36. So 2 desired possible outcomes versus 36 total possible outcomes. The least likely to happen is double sixes. That's just a 1 out of 36 chance.